Which member of the sales team had the highest sales in February? See, this is a multiple. See, there are members of the sales team given. Multiple variables are there. All of them are placed on this axis. Apart from that, see the different aspect about each of their performance during different months. So this black color indicates January. Little on the grayer side, gray shade is February, and then above that it is March. So now the question says, who had the highest sales in February? Highest sales in February.
Sharon need.
Okay. The last one.
Yeah, last one.
So February, how do we know?
The gray portion, that is the mid one.
Gray portion here, but that looks similar to my capstick also. My capstick has made between 250 to, and this comes to 100. So anything between 100 and 150. And here it would be somewhere around this two. This line goes to. Okay, so we can go with the last one, Sharon Newt. Histogram uses a set of rectangles to represent a group frequency table. To be correctly represented, the histogram must show the relationship of the rectangles to the frequencies by reference to which of the following? Height of each rectangle, area of each rectangle, then we see width of each rectangle, diagonal of each rectangle. No. So what's the answer?
Area of rectangle. B, ma'am.
The histogram uses set of rectangles to represent a group frequency table. Is it not just the height of each rectangle? We only measure the height. Are there any other parameters?
So histogram. Yeah, so height of each rectangle.
That's what I understand. That
Yeah.
uses set of rectangles. So these are kind of rectangles. We just take only the height, no, to be correctly represented. Maybe we need to look into the study text content. Histogram. Let's just check this one.
In a bar form, so mostly it's height only.
No, it seems it's area. It says it's area represented by the area of a block or rectangle. So otherwise we generally go with the height.
Height only, yeah.
Only measuring, counting the height part of it, and then what is that? But the explanation given in the study text says that it should be according to the area. So we go with area of each rectangle. Referring to the graph, which statements are true and which are false? So what are the statements? Area 3 shows the best performance in Q3. What? 3 quarter. Area 3 shows the best performance in quarter 3. Area 2 sales are consistent quarter on quarter. Area 2 sales are consistent. Okay. Then Q4 has the largest volume. Q4 has the largest volume across all areas. Okay. Area 1 shows the best performance in Q2. Area 1 shows the best performance in. So if
Yeah, that is true. The area one
we
shows
are
the
to
performance.
write for each of the statements, which one is true or false. Let's take it up. The first one.
Area 3 shows this performance in Q3. That is true.
Area 3 shows the best performance in Q3. Area 3, Q3. So Q3 is little lengthier than the
Other two, yeah.
So this can go as true. Area 2 sales are consistent quarter on quarter.
No, false.
Every rectangle should be equal, but here
Equal,
this
yeah.
part of it is little smaller. So the second quarter is little smaller than the others. Maybe and a quarter 4 is also little longer. So we cannot say that this is consistent quarter on quarter. So this goes false. Q4 has the largest volume of sales across all Q4s are taller than the others. So here we have it as true. Area 1 shows the best performance in Q2. Area 1, Q2. Q2, this is longer than
the other two. So
okay, so this is true. Which of the following statements is not true? Histograms plot frequency against area. Or gives plot cumulative frequency distributions. Not true. Okay. If you want to compare totals where each data set can be broken down into further data sets, a compound bar chart would be more useful than a multiple bar chart. Scatter diagrams plot a dependent variable against an independent variable. So which one of it is not true? What are histograms? We have histograms are on one side we have one variable, on the other side we have another variable. That's it. We raise the bar. See, like in the previous example also, we see on one side we have the area, the other side we have the sales volume in each of these quarters. It is not against the area, but it is one variable against another variable. Augits always plot cumulative frequency distribution. That's also correct. If you want to compare totals where each data set can be broken down into further data set. Compound bar chart, that's also correct. Scatter plot diagrams plot a dependent variable against an independent variable. So not true goes with A. There are two variables, it is not against the area. A frequency distribution of a sample of monthly incomes is as follows. If the rectangle represents income between 800 to less than 1000, has a height of 8 centimeters, what is the height of the rectangle and less than 1200? And 1000. I have no clue how to answer such a question. Maybe let me look into that. I have no clue. I have not solved any time a question like this. 23 people out of 0. Less than
Maybe cross multiplication.
cross multiplication. Help me the logic. So this is frequency and we are given some details about height, isn't it?
Yeah.
So if the between 800 to 1000 has a height of 8 centimeters. After that, the height between 1000 and 1200 is, what is the height between?
So frequency is 16 for 800 to 1000 and has a height of 8 centimeters.
These are the logic. I didn't solve any time a question like this. Okay.
No, because I am doing financial management, the cross multiplication is stuck in my head, ma'am. So I was.
Oh.
So for 1000 and 1200.
Is it? Then in that case, it would be 8 into 16 by 7.
No, but for we have to find out for 1000 and less than 1200, no, ma'am. Like we don't need to consider the 7 part itself. It's 16 and 28 will be taking into account since we have to find out for
Okay,
1000
for
and less than.
800 and 1000, it is 8. The first one
Yeah.
we do not know. Okay.
In the second part, we have to find out.
1000 and 1200 is what?
Yeah, 8 into 28 divided by 16.
Okay. So the first one, there is no information provided. We do not know what's that information. Okay, so this is the case.
We come to 14.
Okay, this is a new thing for me to learn. 14, no? 8.
Yeah, 14 months.
14 centimeters. Let me remember. Let me also read through some articles about this. I actually don't have any information. Which of the following qualities is not necessarily a quality of good information? Quality of good information is based on the acronym ACC UA accurate. So it should be relevant, that is correct. Then it should be understandable, that is also correct. U is there. Then it should be worth more than its cost. So that is also cost effective. It should be available quickly is not the case. It is not there. Cost beneficial, whatever is the cost that is spent, the benefit should exceed that. It should be available quickly is not the point. Which of the following is correct? Qualitative data is generally non-numerical information. Qualitative. There are two types of data, quantitative data and qualitative data. Quantitative data is in the form of facts and figures. Qualitative data is in the form of, see, it could be numerical also, but most of the time it is in the form of opinion. Okay, qualitative data is generally non-numerical information. Information can only be extracted from external sources, nothing like that. Operational information gives details of long-term plans only. Quantitative data is always accurate. That also could have flaws in that. So this is generally non-numerical, but it doesn't rule out that anything would be in form of numerical. That also is a possibility. So therefore, A would be the correct answer. So then again, which of the following would be classified as data? Number of purchase requisitions, analysis of wages into direct and indirect costs, table showing variances from budget, graph showing the number of labor hours worked. Data is unprocessed. It is just collection of facts and figures. Which of the following would be classified as data? Later on, data is processed and it is presented as information. Okay, so which one is just facts and figures? The first one is number of purchase requisitions. The other three, all of them are processed. Analysis of wages is taken up. That table showing variances, that is even further. Not only arranging it in a table, but from the table variances are also drawn. Graph showing the number of labor hours worked. So that is a graphical presentation taken up. So data is just in the raw form, number of purchase requisitions. Which of the following statements is or are true regarding the qualities of good information? So it should be communicated to the right person. It should always be completely accurate before it is used. It should be understandable by the recipient. Understandable by the recipient, yes. Accurate. The acronym accurate says accurate. Then we see it should be communicated, it should be cost effective. So on that note, communicated is also fine. It should always be completely accurate before it is used. It should be validated, but assured, because the data could have errors. See, the quality of the characteristics of good quality data is that it should be validated for its accuracy, but completely ensuring that it is always to be completely accurate. It doesn't happen. There may be errors on account of so many aspects. So therefore, on that note, though it has to be accurate, completely accurate on that point, completely, it should be accurate. Yes, that is the first feature about good quality information. But 100% or completely accurate is humanly not possible. So we cannot go with that, and then it becomes false. Which of the following only contains essential features of useful management information? Accurate, understandable, presented in report format, timely, reliable, supported by calculations, regular, complete, communicated in writing, understandable, accurate, relevant for its purpose. So in the wrong answers, one aspect is wrong. So the one which has all correct, depending on the acronym accurate, we see that the first one has Accurate is correct, understandable is correct, but presented in report format is not a part of it. Timely, reliable is also correct, supported by calculations is not there. Regular, see, it has to be communicated, but specifically as communicated in writing is also not there. It is relevant, it is not regular. Okay. The last one has all three of them correct. Understandable, accurate, relevant for its purpose. Which of the following describes information? Data. What is information? Data which is processed is is called as information. Processed in the sense, maybe some kind of arrangement is taken up, that is, it is arranged in rows and columns, and uh, so that analysis can be uh, further analysis can be taken up, and it is present, it can be presented for a decision making. Okay, so that is what is information. So data that consists of facts and statistics before they have been processed. Before they have been processed is data itself. It is not information. If no processing is done, it's only the collection or gathering of facts and figures. It's called data. Data that consists of numbers, letters, symbols, events, and transactions which have been recorded, but not yet processed into a form that is suitable for decision making. The point not yet processed makes it only data. It doesn't make it as information. Facts that have been summarized but not yet processed. Not yet processed. The whole thing is about processing. Processing of data is information. So last one says that data that has been processed in such a way that it has a meaning to the person who receives it, who may then use it to improve the quality of decision making. So 171 is D. It has been processed. That's the point. All the other 3 points say that it has not yet processed, has not been processed. So if it is not processed, it is still data. 172. Which two of the following statements relating to big data are true? We have not discussed anything about big data until now, because the concept of big data was falling into the next topic. Because we still have to do um, index numbers. We will be doing that. After that is interrelation between variables. That's a this topic has this concept of big data. So big data correlation coefficient, and then the last is forecasting. So in that particular chapter, we see that there is a concept called as big data. So why do we have to study here is see, what is big data? You must have heard about it. The concept of big data, since we are studying about data and information, um, at the beginning I have mentioned that the collection of facts and figures is data. Data is processed into information. Conventionally, data was collected from internal sources and external sources. Internal, the records and registers that were maintained by the organization. So anything collected from that is internal source, and external source would be that is published sources by government, private bodies, etc. All that is um, external sources from the published source. Of late, because of the technological advances and the evolution and revolution of internet, see, anything which is transmitted also is called as data. So as the data that is transmitted, when it is captured, that also is data. So the third source is when data is transmitted from one device to another device, if it can be captured, and that becomes data. So is it possible to capture? Yes, it is possible to capture because of digital marketing tools. So this is more reliable because the seller will be able to understand what is the requirement of the buyer, the consumers. So as they keep searching on the internet or they share messages with others, so it becomes possible to understand the mind of, understand the requirement of the buyer, and can be catered. So now, if it is captured, then we understand that the data that is captured across the globe, we see that the number of smart devices as of now are more than the human beings that are existing on the earth. That also we know. And most of them are connected. The devices are all connected to the internet. When they are connected to the internet, and any message that is shared, if it can be captured, is also data. So the size of the data has, because of that reason, become very big data. When the size of the data increases, when the size becomes big, then see, the data, why is it collected? The first point, data is collected, it should be accurate, relevant, etc. All that processed into information, then analyzed. Analysis is useful for decision making. So this big data is also useful for decision making, analysis and decision making. But if the size is big, see, earlier the standard computers were unable to process such large volume of data. But later on, because of certain softwares that were introduced, big data softwares, with the help of big data softwares, it has become possible to even analyze that large volume of data. So there are attributes of big data also. Let's just look into that. Regular data becomes big data when it is large enough that it cannot be easily processed using conventional methods. However, one process, big data, can be very valuable. So now, because of softwares, like we have a software called as Hadoop, so those softwares which can be used, and the data can be processed. So actually, there are attributes of big data. All of them are given as B's. The first B talks about the volume. The volume of big data is big in size. The name itself says that big. So how big is the data? If we are to talk about how big is the data, that the data, if it is cannot be stored on the storage device of the organization, or the storage, if it exceeds beyond the storage capacity, then for that device the data is big. Okay, so for an organization, they also have some internal storage devices. So all the data, if they capture, is cannot be stored on the storage devices, then the size of the data has become big. Then what do? So they store it on the cloud computing. We also store on Google Drive, is a store external storage device. So we also share our photos and etc. on Google Drive. It is there on the internet. So the volume is so big that it cannot be stored on the storage facility of the organization. Second attribute is also a B. All of them are expressed as B's. The second one is velocity. See, this data that is captured, see, any data that is captured, it makes any sense only if it is used for decision making. So the entire purpose of it also is to be used for decision making. So it has to be analyzed. If it has to be analyzed, as it is, the size of the data is big. So when the size of the data is big, and if it has to be processed, then in that case, um, how, because the size is already big, how quickly can the processing take place? So the velocity talks about the speed with which the data is processed is quite high. With high speed the data is processed. The best example what we can quote about big data processing is, see, in the stock markets we see that as the trading is taking place, we see that the data gets updated. When the data gets updated, we see the analysis coming out almost immediately. It doesn't take much time for the analysis to come out. It is almost on par, or very quickly the analysis is out. Why? Because the as the data gets updated, that updated thing also is considered by the big data analysis. That is, the softwares consider every fraction of second any change that happens, and we can see that the analysis also is almost immediately given. So, which means that with such great speed, even if it is big data also, with such great speed, the analysis can be given. So the velocity talks about the speed with which the data is processed. The third V talks about variety. See, what is variety? Variety is the data. It is not only numerical. Okay, we have different types of data, that is quantitative, qualitative. Quantitative is only numbers in numerical form. Qualitative is both numerical and non-numerical, that is in the form of opinion. We have types of data called as structured data, unstructured data. See, what are unstructured data? Anything like a video, audio, text message, a picture, image. So these things are also data. So even these kind of data which are unstructured, which cannot be properly organized into a set pattern, such data also is considered for analysis. So big data can process variety of data. There are data that is collected from a variety of sources. All of them are taken and then they are processed. So that's variety of data. Volume, velocity, variety. Fourth one talks about there is veracity. What does it mean by? See, since the data is collected from multiple sources, this data has to be verified for its, it has to be validated for its genuinity. Because the data is collected from multiple sources. The third one is the transmitted source. So we also know that that is the data that is um, circulated on the internet, most of it is fake. We also know that. So the messages which we receive, we also understand that half of them is fake information which is circulated. So such kind of data, if it is captured, so the genuinity, the truthful nature of the data also has to be validated. Can it be relied? See, it is, if it is not validated, if it is not verified about its genuinity, wrong data can be used and the analysis also would be wrong, which is not dependable. So that is a danger for the organization. So the fourth one talks about veracity. Veracity is that the data for its genuinity has to be validated. These are the four uh, attributes or characteristics of big data. So regular data becomes big data when it is large enough that it cannot be easily processed using conventional methods. However, once processed, big data can be very valuable. Okay, large volume of data if it is taken. See, otherwise it's the entire data, if it is not considered, only one part of it is taken into consideration, analysis is done, that analysis applied to the entire data. See, it's not so very reliable. The entire data, if it is taken for analysis, it is more reliable. Okay, so even if it is big in size also, because of the big data analysis tools, it is now possible to analyze the large volume of data. So it is very useful. Allows businesses to expand their knowledge of their customers and develop products and services that are best suited to customer needs. Gives businesses a deeper understanding of how their customers behave, allowing them to connect with customers on a more meaningful level. Then it says helps boost marketing activities since it provides businesses with a chance to analyze customer behavior. That's what is happening. See, of late, anything what we I mean search for or type for on the internet, if on the social media platforms or just the search engines or somewhere where the data is can be captured, in that case, what is actually happening is the sellers are attracting the customers direct with their direct messages or advertisements or somewhere the pop-up messages come up and then they try to attract the customers, or they are able to directly get connected to the buyers or the customers and then market their products. So that is the advantage of big data analysis. So that is that the sellers are able to understand the customers, their requirements much better, and are able to cater to the requirements of the customers. Okay, that's all what is given here as part of big data. Only one small concept, I mean, slide is there for us. So let's look at the question and then 172, which two of the following statements relating to big data are true? Big data refers to any financial data over $1 billion. Managing big data effectively can lead to increased competitive advantage. Okay, the term big data means data that comes from many sources. Big data contains both financial and non-financial data. We are asked to choose two statements that are true. First one is not true. It is not based on the worth of the data. It is based on the size of the data. Size of the data as big that it cannot be stored on the storage devices. Okay. Then second one says that managing big data effectively can lead to increased competitive advantage. Yes, we can see if the big data analysis is available, more reliable analysis is available, so they can have a better advantage over their competitors. So that is it can lead to increased competitive advantage. That will be true. C says that the term big data means data that comes from many sources. See, that is the term big data doesn't mean, but one of the attributes of big data is a variety of sources from which the data is collected. But the data, big data is data which is big in size, not about it is coming from variety. It is also one aspect of it. Okay. Then we see fourth one, big data contains both financial and non-financial data, variety of data. Fine. So here we see that three of them are correct. We are asked to select only two of them. Managing data effectively can lead to increased competitive advantage. Very true about that. There is no doubt in that. Managing big data effectively can lead to increased competitive advantage. Okay. It is more dependable, reliable. That is the answer. But then now we have C and D. Only two are asked to be selected. So big data contains both financial and non-financial data. So it is the data has financial data, non-financial data, structured data, unstructured data. Okay. Both of them are talking about different types of variety of data from many sources and financial and non-financial data. Both of them have the same aspect, comes from many sources. It has variety of data. So it has both financial and non-financial data. Maybe sometimes it may not come from many sources. So it may be only one source, but the data that is collected is big in size. So the concept of it is variety of data. We cannot say that only when it comes from multiple sources or variety of sources or different sources, we call it as data. It has to be big in size. That's it. The sources may be limited. So on that note, but otherwise C also seems to be closer to D. We select here D because it contains both financial and non-financial data. It could be only very few sources also. See, if we have um, national census, let's say that census is, of a particular country is collected. See, all the data about the male, female population, urban, rural, employed, unemployed. See, all of them, all that information can be acquired from only one source, that is from the census. So, not necessary that only when they come from multiple sources that we call it as big data. So, therefore, on that note, C is not selected. Which three of the following are typical problems that organization may face when dealing with big data? Three have to be selected. The increasing use of electronic devices within society at large. A lack of skills in the labor pool relating to the handling of. So, what are the typical problems? So, here the question is addressing about what are the typical problems. A lack of skills in the labor pool relating to the handling of big data, legal and privacy issues if data is held about individuals, measurement of metrics that have no use to the organization, inability to monitor information from social media sites. So, advantage wise, it can have a competitive advantage. If they can do better, they can understand the customers' minds and then requirements and cater to the customers very immediately, etc. So, those are all advantages of big data. But then, big data also has certain problems and then limitations. So, one thing is not many are aware of how to analyze big data. So, there is lack of skills. Okay. See, the increasing use of electronic devices within society is not a problem. That is, in fact, actually, that is a source from which they can get the data or the information. So that is a source. Multiple electronic devices are there. They are connected to the internet. Then data is generated and that data is captured. So that becomes a source. We cannot call that to be as a problem. Second one is a problem because people are see, though data is captured, that data to process that, people should be equipped with the skills of big data analysis. So because of lack of that, though data is captured, collected, it cannot be processed. So we see that there is lack of skills in the labor pool relating to the handling of big data. That is correct. C also we can say it is correct because legal and privacy issues if the data is held about individuals. Data confidentiality is always a big issue. Okay, if it cannot be handled properly, because when the data is analyzed, when the data is captured and analyzed, if it is sensitive data and if there is no protection to such data, because multiple people have to handle this data, any kind of an issue, privacy issue arises, and then that can put them into trouble. So that is another problem. Then measurement of metrics that have no use to the organization. Last one says that inability to monitor information from social media sites. See, measurement of metrics when the data is collected, which is large in size. After the data is collected, the data is grouped into clusters. The data is arranged into tables, etc. Then the analysis begins. So sometimes because large data is collected, in that large data some of the metrics may be absolutely not useful for them, but they cannot streamline it and then eliminate the unnecessary data. It also comes as part of one part of the data. So any kind of metrics which are not related to the business or are not useful to the business, the measurement of metrics that have no use to the organization is again a problem to the organization. Inability to monitor information from social media sites. So it is not about monitoring the social media site. It is only to capture the data from social media sites. After capturing, it is validated for its genuinity. It is not, as the data is being circulated on the social media sites, it is not about monitoring the information. It is just to capturing and then verifying it whether it is useful or not. So on that note, E cannot be the answer. So we now are moving into the next topic called as index numbers. So we are done with this one, and now we have to talk about what are index numbers. Macroeconomic and institutional context 3, index numbers. So what are index numbers? So we would be looking at simple index numbers and change of base, then linking series, composite index numbers, base or current variety, and price indices. I'll just give a small introduction about what are index numbers, and then shall I wind it up after giving the index numbers? Am I audible?
Yes, ma'am, you're audible.
No, I asked you, shall I wind it up after giving an introduction about index numbers?
Yeah.
No, actually, I have to attend a webinar at 2 o'clock.
Okay.
Back to back it would be. And not much
Sure.
much content is there. Therefore,
We'll be finishing the class on Wednesday, ma'am, or it might get
in
extended?
any case, it will be done by Wednesday.
Okay.
The concept of index numbers is the as the time passes by, there would be changes in the value of certain items. So there would be change in the prices. So whenever there is a change, so what is that change and expressed in terms of percentage is index number. An index number indicates that there is a percentage change in the value as compared to the base year. So this is important to understand, to calculate, to check whether um, to check about what is the percentage change in the variable happening over a period of time. The series of values related to different times are all expressed as a percentage of the value for a particular time. Then they are called as index. So if we have a base year, value for a base year is given, base year would be taken as 100%. The current year, whatever is the year for which we are verifying, the current year is what percentage? So current year into 100% divided by base year gives us the index number. Okay. Now, what's the choice of the base year? The base year should be a fairly typical year with when nothing unusual occurs to the values. So consistently when the data value is there, so out of that 1 year which is selected as a base year should be a part of that series. But sometimes we see because of fluctuations in the economy, there are many changes in the data also. So any such year where there are too many fluctuations cannot be selected as the base year. So that's one point. A sufficiently recent year for comparisons with it to be useful. See, 20 years back cannot be taken as the base year. See, we are only talking about what changes are taking place in the recent past. So out of the recent years, 1 year which does not have too much fluctuation should be selected as the base year. The present year is what percentage? Then if you want to change the base year of a series of index numbers, you can treat them exactly as if they were the original data. So how do we calculate? Index with new base is equal to index for the new base year, the old base year into 100 by the index for the new base year. So old base if it is 100%, new base is what percentage. So the same logic applies here. So we have years given for 2001 and then 2000, year 2000, year 2001, year 2002. So index bases are given here, and index base for 0, 1. If we are to calculate index for 0, 0, with 0, 1 base is equal to, we just have to, if the base is moved to 0, 1, then 0, 1 data, if it is 0, 1 is the base, index for 0, 0 with 0, 1 as the base. So if 150 is the base, 150, this one, 150 is 100%. So 0, 0 is 100. If this is 100, so base is always denoted to 100. The new change, whatever is that, that is also 100. So 100 is what percentage? So that is the logic. So if index for 0, 2 with 0, 1 base, 183, see 150, if it is 100, 183 is what percentage? That is as simple as that. The logic is also same. So if it is simple index numbers, we take the base year to be as 100%, and the current year is what percentage. Okay, then we have different types of index numbers calculated. One is linking series, composite index, then how to calculate price indices, quantity indices. Linking series, change both to have with the overlap year as their base. After that, change the combined series to whatever base year is wanted. So there are years given, 97, 98, 99. Index is given. If they are to combine the index, 98 is equal to 100. Then if 98 is equal to 100, see, we see taking the base as 98, the index 1, which is given here, is 219. Okay, if 219 represents 100%, the previous 97 year is what percentage? So that's calculated. 210 is what percentage? 210 into 100 divided by 219. Okay, so that calculation, it is calculated, and the index is given to us as 96. Similar, index 2, according to index 1, we don't see that there is any index here 99, but 97 is the index according to index 2. So that is also calculated like that. The questions also, we will be, when we take it up, we can look into what calculations are to be taken up. The whole concept of index numbers are calculated to understand what is the rise in the prices, what is the change in the value of the variables as compared to the base year. So there are various ways in which index numbers are calculated. See, simple index only talks about, see, the base year is equated to 100%, and the current year, the present year is what percentage. So that's all what we have to look into. So as we proceed further with doing the calculation, we would be better understand that. Okay, we have composite index, that is weighted average index can be calculated. That is, it's on, just not only the price, but along with the price, the respective quantities are also taken into consideration. The quantities will be considered as weight. So weight into price is multiplied divided by the sum total of weight. That is the weighted average. So in that case, the index also can be calculated as, 1 second, let me take the call. So that is also a way to calculate. That is, it's just not depending on the prices, but along with the prices, the weights are also taken into consideration. Okay, then that is called as composite index. We only can also calculate just with the prices. The price in the base year is P0, the price in the current year is P1. Then one way is to take the weights also in the also take the weights, but that's only for the base year. So there are certain indices given based on current year price and current year quantity plus the base year price. Sorry, base year price and base year quantity and the current year's price. So taking these things also, the index numbers are calculated. Then we have quantity index. See, quantity index, that is taking into consideration what are the quantities. We will discuss all of them method by method and look into that. So on this note, I just want to wind it up today. We have round about some 8-9 questions are there, so we can do it tomorrow.
Yeah, ma'am, sure.
Tuesday and then Wednesday. 2 days, if we take the classes, that should be done, and then we would be winding up by Wednesday. Okay, I have a
Yes, ma'am.
webinar to attend now.
Yeah, sure.
Some ACCA program. So on that note, I just want to wind it up. Okay, good day.
Yeah, sure. Bye, ma'am.
Bye. Bye.